Hello dear students. So welcome back to my video lecture 9 on hydrogen and its compound. So in this video we will be talking about something called as heavy water. Okay, heavy water, not an ordinary water. What is this called as? Heavy water. Okay, and what is the molecular formula of heavy water? It is D2O. D2O. Well, so in the previous video we were talking about water, the physical properties of water, the chemical properties of water, okay, hardness, most importantly the hardness of water and the different methods to remove the hardness of water we have discussed, okay, for temporary hard water also as well as for permanent hard water also. Just recall, for temporary hard water we have two methods, one is by boiling, the other one is by Clark's method, and in permanent hard water we have got four methods. One is by adding washing soda, the other one is Calgon's method, next permuted process, and last one ion exchange resin method. Okay, so with all this idea, now it's a very small concept here to learn, okay, but we have to learn, it is important. Okay, so what is this? It is, okay, heavy water. Okay, so shall we start with heavy water now? Yes. Okay, so students, heavy water, what is this heavy water and how is it different from normal water? Okay, we know, yes, we know hydrogen exists in three isotopic form. Which are those three isotopic forms? Okay, one is protium, deuterium, tritium. 1H1, 1H2, okay, 1H3, isn't it? Okay, now if this deuterium, okay, forms oxide with oxygen, then that resultant is called as heavy water. Okay, it is called as heavy water. Why it is called as heavy water? Okay, why not ordinary? Why it is called as heavy water? Because we know the atomic mass of deuterium is more than that of protium, isn't it? The atomic mass of deuterium is more than that of protium. Okay, since the atomic mass is heavy, okay, since the mass is heavy, that is why it is called as what? Heavy water. Since deuterium has more atomic mass than the ordinary hydrogen, okay, the resultant water is called as heavy water. Heavy water. Okay, now let us look into the preparations of heavy water, the different properties of water, chemical properties of water, okay, heavy water, and the uses of heavy water in this video. Understood? Okay, yes. So how do we prepare heavy water? Now, okay, preparation of heavy water. Okay, yes, we have got only one technique. Okay, preparation of heavy water. Heavy water. Okay, what are the different methods of preparation of heavy water? Okay, yes, the first, no, only one method we have under the preparation of heavy water, that is called as, okay, yes, this method is called as prolonged or exhaustive hydrolysis of water, normal water. Exhaustive hydrolysis of water will gives rise to heavy water. Okay, will gives rise to what? Heavy water. Exhaustive hydrolysis of water. See, always you should remember that with normal water there will be, okay, traces of heavy water. There will be traces of what? Heavy water. I have told you in the very beginning of my class, okay, in nature, okay, protium is about, okay, 99.9%, okay, abundant in nature. Okay, deuterium is, okay, 0.015% abundant, and tritium is, okay, yeah, 10 power minus 15% abundant. Okay, isn't it? 10 power minus 15% abundant, is it? Okay, so majority is, protium is very abundant. Okay, yes, deuterium is abundant in slight amount. Okay, tritium in very small amount, 10 to the power of minus 15 or 10 to the power of minus 5. Okay, yes, so now majority will have protium, then deuterium and tritium. Okay, they exist together, no doubt in it, but abundant, most abundant is protium, and the next abundant is deuterium. So that is what I am telling you. Okay, along with normal water, there will be traces of, okay, there will be traces of heavy water. Now, okay, if you just electrolyze this heavy water, okay, if you break this, keep on breaking this, okay, heavy water several times. Exhaustive hydrolysis means hydrolysis has been done several times, not just one time, two times, three times, okay, several times of electrolysis of normal water will give heavy water. Trust me, if you electrolyze normal water, see, if 29,000 liters of normal water is electrolyzed, if 29,000 liters of normal water is electrolyzed, we will get 1 liter of heavy water. Okay, we will get what? 1 liter of heavy water. That means how many times, okay, you have to electrolyze the normal water. Okay, so exhaustive hydrolysis of, okay, normal water will give rise to heavy water. Okay, normal water will be associated with traces of heavy water. Okay, so 29,000 liters of heavy water will give rise to, electrolysis of 29,000 liters of water will give just 1 liter of heavy water. Okay, got it. So now what happens during electrolysis? Look here. What happens during electrolysis? Okay, so what does water consist of? Water, we know water consists of, normal water consists of, okay, yes, H plus ions and OH minus ions. Okay, heavy water consists of what? D plus ions and OD minus ions, isn't it? D plus and OD minus, is that correct? Okay, now what happens during electrolysis? Okay, so what you will do is, okay, you will dip platinum electrodes to water and you will pass high voltage of current. Okay, you will dip platinum electrodes to water and you will pass high voltage of current. Okay, so what happens at cathode, what happens at cathode, and what happens at anode? Okay, what happens at cathode and what happens at anode? At cathode, H plus ion, okay, H plus ion, okay, will accept electron and it will be reduced as hydrogen gas. Okay, yes, at cathode, H plus ion of H2O will accept one electron and it will escape as what? Hydrogen gas. That means at cathode, H2 gas, hydrogen gas will be liberated. Okay, whereas D plus ions will remain in the solution. Okay, nothing happens to D plus ion, it will remain in the solution. The solution, okay, what now? This is the solution inside the electrode or cell. It is consisting of H plus ions, OH minus ions, D plus ion, OD minus ion. Okay, only H plus ion at cathode will take electron, okay, and hydrogen gas will be liberated and D plus ions will remain in the solution. It will remain in the liquid form. Okay, now what happens at anode? At anode, that OH minus ion, okay, yes, OH minus ion will get oxidized to, it will get oxidized to oxygen, okay, oxygen and water by liberating 4 electrons, Therefore, hydrogen, H plus ion is going out as what? H2. OH minus ion is going out as what? O2. Okay, H plus, okay, gradually H plus ion and OH minus ion will, okay, yes, will vanish, isn't it? Okay, gradually, if you keep on electrolyzing it many times, okay, gradually the H plus ion and OH minus ions will vanish and what else will be left with? Okay, we will be left with only D plus and OD minus. These two will combine to form what? Heavy water, isn't it? When all the, okay, H2O and when all the water molecules are electrolyzed, we will be left with heavy water. Okay, this technique is called as exhaustive hydrolysis of water. Exhaustive hydrolysis of, okay, water. So this will give rise to what? Heavy water. Now, what are the physical properties of heavy water? What are the physical properties? Okay, see, okay, I told you the atomic mass of deuterium is more than that of protium, isn't it? Since the atomic mass of deuterium is more than that of protium, all the physical constants of heavy water is always more than that of, okay, normal water. Please understand. Okay, I'm talking about the physical properties. Physical properties. Physical properties. Understood? Okay, so here I'm telling you, since atomic mass of deuterium is more than that of hydrogen, okay, almost all the physical constants, okay, physical constants of heavy water is more than that of normal water. Is more than that of what? Normal water. Since atomic mass is more, okay, all the physical constants of heavy water is more than that of what? Okay, water, normal water. For example, I'll give you one simple example. What is that example? Yes, okay, one simple example. Look here, okay, we know the boiling point of water. Boiling point of water is 100 degrees centigrade, isn't it? Boiling point of normal water is 100 degrees centigrade, whereas boiling point of heavy water is 101.4 degrees centigrade. Look at here, boiling point of heavy water is more than that of what? Normal water. Like that, if you take up any physical constant of heavy water will be more than that of normal water. And one more thing you should remember, okay, heavy water is again a colorless, a tasteless, and it is a mobile liquid. It is a mobile liquid. Understood? That's it. So there is nothing else with respect to the physical properties of heavy water. Now we will quickly look into the chemical properties of heavy water. Okay, chemical properties of heavy water. Okay, see, heavy water resembles normal water in its chemical property. That means it exhibits almost same chemical properties as that of normal water. Let us compare the chemical properties of normal water with heavy water. Okay, yes, let us compare the chemical properties of normal water with heavy water. Okay, with heavy water. Okay, yes, look here. Now we know when, okay, yes, sodium oxide dissolves in, okay, water, normal water, yes, what is it going to form? It will form what? Sodium hydroxide, a base. When any metal oxides dissolves in normal water, it will form their hydroxides with the liberation of which gas? Hydrogen gas, isn't it? Just like this, even when the metal oxides, okay, dissolves in heavy water, they form their respective hydroxides. Okay, it is 2NaOD, OD this times. Okay, and which gas is liberated? D2 gas will be liberated. D2 gas will be liberated. It is very similar. Okay, just like when, yeah, okay, calcium carbide, CaC2, when calcium carbide, okay, so it reacts with, okay, when calcium carbide reacts with what? Water. When calcium carbide reacts with water, we know it forms calcium hydroxide and ethene, isn't it? Okay, it forms calcium hydroxide and ethene. In a similar way, okay, when calcium carbide reacts with heavy water, here also it will form what? Okay, deuterated hydroxide of calcium, okay, plus C2D2, okay, yes, deuterated ethene. This is called as deuterated ethene. Understood? Okay, any doubts? Yes. Next, when aluminum carbide, what's the formula? Okay, when aluminum, let us say aluminum nitride, okay, when aluminum nitride reacts with water, what is going to happen? It will give aluminum hydroxide and ammonia, correct? And ammonia, isn't it? Just like this, when aluminum nitride reacts with heavy water, it will give, okay, deuterated aluminum hydroxide plus, okay, deuterated ammonia, ND3, deuterated ammonia, ND3. NE3, ND3. Okay, is that correct? Any doubts? Okay, now what if you electrolyze water? We know if you electrolyze water, it will give hydrogen gas and oxygen gas, isn't it? Okay, just like this, if you electrolyze heavy water, it will give, okay, D2 gas and oxygen gas. Okay, so like this I can say, yeah, okay, chemical properties of heavy water resembles the chemical properties of normal water. Okay, there is nothing more than this. Now at last, okay, very important, because many a times the questions have been come from this concept. What is that concept? Uses of heavy water. Okay, what are the uses of heavy water? Okay, so you have to concentrate here. It's quite important because questions have come, okay, from this concept. Yes, uses of heavy water. What are the uses? Okay, observe here. Uses. Okay, so what are the uses? Two uses. Just remember the two uses. Since okay, yeah, heavy water absorbs neutrons. Okay, since heavy water absorbs neutrons, okay, it is used as a moderator. It is used as a moderator in nuclear, okay, power plants, isn't it? Okay, or in nuclear reactors. Okay, so are you getting my point? Since heavy water, it absorbs neutrons, that is why it is used as a moderator in what? Nuclear reactors. Got it? Okay, and one more very important use of this heavy water is, okay, see, yes, what are the uses here? Okay, yes, see, okay, it is used as, okay, a tracer compound in organic reactions. What do you mean by this? Used as a tracer compound in organic reaction. See, I'm going to consider one important reaction. This is called as esterification reaction. What is this called as? Which reaction is it? This is esterification reaction. Okay, what is esterification reaction? When carboxylic acids reacts with alcohols, ROH. When carboxylic acids reacts with alcohols in the presence of concentrated sulfuric acid, okay, okay, water will be eliminated, okay, to give what? An ester. Water will be eliminated to form an ester. Okay, this reaction is called as esterification reaction. Okay, observe here, we know carboxylic acid is an acid. Okay, and yes, so here, okay, since carboxylic acid is an acid, hydrogen must have been eliminated from carboxylic acid, but in this reaction hydrogen is getting eliminated from alcohol and OH is getting eliminated from what? Carboxylic acids. Okay, OH is getting eliminated from carboxylic acid and H is getting eliminated from alcohol. Now I want to confirm from which compound hydrogen is getting eliminated. So what I'm going to do is, okay, so I'll okay, replace this hydrogen with deuterium. I'll replace this normal, okay, hydrogen with what? Deuterium. Okay, what will happen? RC double bond OH, carboxylic acid. Now it is treated with ROD. Okay, same in the presence of concentrated sulfuric acid. Now what is going to happen? This is getting eliminated. Same, okay, esters are formed. Okay, what is the byproduct formed here? H or yeah, DHO, isn't it? That is nothing but H2O. Okay, see this. Okay, this, okay, here D is getting eliminated from what? Alcohol, deuterium. Okay, since deuterium is getting eliminated from alcohol, I can clearly say that, okay, hydrogen gets eliminated from alcohol, hydroxyl gets eliminated from carboxylic acid. So like this, deuterium is used as a tracer compound in many organic reactions. So guys, that's all about, that is all about what? Okay, deuterium and heavy water. Now we will be talking about, okay, one of the last compounds of hydrogen, one of the last oxides of hydrogen, that is called as hydrogen peroxide. Okay, yes. Okay, so now we will be talking about the next oxides of hydrogen. What is it? Okay, it is hydrogen peroxide. Okay, hydrogen, okay, peroxide. Okay, what is the formula for hydrogen peroxide? It is H2O2. Okay, yes, hydrogen peroxide. What do you mean by peroxide linkage? See, if there is single bond between two oxygen atoms, okay, if there is single bond between two oxygen atoms, then it is called as peroxide linkage. Okay, peroxide linkage. Okay, look at here the molecule. Can I write the molecule like this? HOOH. This is peroxide. There is single bond between two oxygen atoms, then it is called as what? Peroxide linkage. I told you, in peroxide linkage, the oxidation state of oxygen is going to be how much? -1. Okay, in peroxide linkage, the oxidation state of oxygen is going to be -1. Okay, now here the same, okay, story will hold good. We'll be talking about the preparation, physical properties, chemical properties. Okay, yes. Now, okay, how do we prepare hydrogen peroxide? Well, we have got different methods to prepare hydrogen peroxide. Okay, the first method, what is that we are talking about? We are talking about preparations, the different methods of preparations of hydrogen peroxide. First method, okay, it is called as Merck's process. Merck's process. Okay, yeah, what do you mean by Merck's process? Yeah, here what we'll do is, let us take sodium peroxide, treat it with, okay, icy cold, okay, treat it with icy cold sulfuric acid. Okay, when sodium peroxide is treated with icy cold sulfuric acid, okay, what is going to form? H2O2. What is formed? Sulfuric acid is formed. Okay, sorry, H2O2 is hydrogen peroxide is formed plus Na2SO4, sodium sulfate. Got it? Such a simple reaction. Okay, what is this process called as? This is called as Merck's process. Merck's process. Understood? Okay, yeah. Next one. Next, okay, what is the next one? Okay, we can prepare hydrogen peroxide from, okay, hydrated barium peroxide. Hydrated barium peroxide. Okay, yes. How do you prepare? Okay, yes, from hydrated barium peroxide. Okay, what do you mean by hydrated barium peroxide? It is BaO2.H2O. When barium peroxide, I told you in the previous video, what do you mean by hydrated compounds? If water molecules are associated with a particular compound, then that compound is called as what? Okay, hydrated compound. So when hydrated, here also, hydrated barium peroxide is treated with sulfuric acid. Okay, yes, is treated with what? Sulfuric acid. H2 plus O2 gives rise to what? H2O2 plus what else is formed? Ba plus SO4, barium sulfate. Okay, and water molecules gets evaporated. Okay, water molecules will vanish. Okay, so got it? So that is how we'll prepare hydrogen peroxide from barium peroxide. Okay, now there is one more very important method. Okay, very important method. Okay, what is that method? Okay, this is the third method. The third method is called as, okay, what? Okay, prolonged hydrolysis of okay, sulfuric acid. Prolonged hydrolysis of sulfuric acid. Third method. Okay, so here what you will do is, okay, you'll dip platinum electrodes or graphite electrodes to sulfuric acid and will pass high density of current. Okay, high current density. That means you will pass high voltage of current. You will dip platinum or graphite electrodes into sulfuric acid and you will pass high voltage of current. Okay, so what happens? This is for a long time, for a very long time. That is called as prolonged hydrolysis. Okay, so you'll keep on. Okay, it is not hydrolysis. This is called as electrolysis. Prolonged electrolysis of sulfuric acid. Okay, yes, so what you're doing here in sulfuric acid, okay, so you'll dip graphite rods or platinum electrodes and you'll pass high voltage of current. Okay, so what happens during the electrolysis of sulfuric acid? Look here, okay, H2SO4, can I write this as HSO4 minus, okay, and H plus? Yes, okay, HSO4 minus and H plus. Now, okay, this HSO4 minus okay, gets converted to H2S2O8, liberating 2 electrons. Liberating how many electrons? 2 electrons. HSO4 minus gets converted to H2S2O8, okay, liberating 2 electrons. What is this H2S2O8 called as? This is called as peroxo disulfuric acid. Peroxo disulfuric acid. Understood? Okay, what is the sulfuric acid called as? Peroxo disulfuric acid. Okay, got it? Clear? Yes. Now the reaction is not complete. So this peroxo disulfuric acid, okay, will combine with water molecule. Okay, again it gives what? Hydrogen peroxide plus 2HSO4 minus. Okay, hydrogen peroxide and 2HSO4 minus. Okay, got it? Just H2O. So what did we get here? We got hydrogen peroxide. Okay, what is this technique called? A simple technique. It is called as prolonged electrolysis of sulfuric acids. So that's all about the preparation of hydrogen peroxide. Now let us look into the structure of hydrogen peroxide. Okay, yes, what about the structure of hydrogen peroxide? Okay, yes, structure of hydrogen peroxide. Okay, yes, we will say hydrogen peroxide will have open book like structure. Open book like structure. Open book like structure. Are you getting my point? Okay, yes, what is the structure of hydrogen peroxide? It is open book like structure. Okay, see, in vapor phase it is something like this. Okay, in vapor phase it is something like this. The structure is like this. Okay, yes, just like this. Open book like structure. Are you getting it? Yes. This is in which phase? Okay, vapor phase. Okay, in solid state also the same open book like structure, but there is a slight change. What is that slight change? Let us understand here. Okay, yes, okay, just look here, it's an open book like structure. Okay, yes, in hydrogen peroxide, okay, hydrogen peroxide, both the oxygen atoms are sp3 hybridized. Okay, both in vapor phase as well as in solid phase, solid state. Okay, both the oxygen atoms are what type of hybridized? They are sp3 hybridized. sp3 hybridized. See this bond, okay, and it is a non-planar molecule. Okay, it is a non-planar molecule. It's a non-planar molecule. Are you able to understand? In vapor phase, the distance between the two the angle between the two planes, this is called as dihedral angle. Okay, this dihedral angle is about 111.5 degree in vapor phase, whereas in solid state the dihedral angle is 90.2 degree. Okay, 90.2 degree or somewhere 92 degree or something like that. Understood? It is 90.2 degree. Okay, so in vapor phase and in solid phase, the dihedral angle in vapor phase is 111.5 degree, whereas in solid phase it is 90.2 degree. Okay, yes, what is this structure called as? This is open book like structure. Okay, so guys, so that's all about okay, the preparation and the structure of hydrogen peroxide. In the next class we will be talking about its physical properties and chemical properties. Thank you.